class, we're going to attempt a sample problem involving the calculation of a confidence interval for the population mean. So here's our sample problem. We have a paper manufacturer is making 8.5 by 11 paper, and of course over time the manufacturer will take several samples to determine whether or not the specifications around the length and the width are in fact being met. So one particular sample, one such sample, involved 100 sheets of paper, and the length of the paper was actually measured. So it yielded a sample mean of 10.998 inches with a standard deviation of 0.02 inches. So we want to find a 95% confidence interval for the true mean length of the sheets of paper being produced. So let's just see the kind of information that we have. We know that it should be 11 inches, which basically should be the population mean, but the process varies. And so we have a sample mean and a sample standard deviation, but we also have a sample size. I'm just going to switch screens here so that I could go to the tablet so I could work this particular problem. Just bear with me for a moment. Okay, so here we are. So what do we know we're given? We're given we believe that the population mean should be 11 inches. Oh, that's what it should be, but it may not actually be that. And we take a sample of 100. We found a sample mean of 10.998 inches, and then a sample standard deviation of 0.02 inches. All right. So we want find a 95% confidence interval for the mean. Let's find that. So find a 95% confidence interval. Oops. For mu. Okay. So what do we need to do is to identify the right formula. If you look, we do not know the population standard deviation. So in this case, we know that sigma is unknown. And so if we look at the sample size, the central limit theorem should tell us that we can use a normal population as an approximation for the sampling distribution of x bar, in which case then we would use the following formula: x bar plus or minus z s over the square root of n. So notice that I'm not using sigma, I'm actually using s. Alright, so all we need to do is just plug in the right numbers here. We know that x bar is 10.998. What is z? Well, for a 95% confidence interval involving the normal distribution, we know that z is 1.96, and our standard deviation is 0.02. We divide that by the square root of 100. So for those of you that are wondering, well, where did this 1.96 come from? If we take the standard normal and we want a 95% confidence interval, that means the area in here must be 95%, 0.95. But our textbook, remember, works with just half of this. So if I look at just half of the distribution, that portion is 0.475. The corresponding z for that is 1.96. Remember, the 0.475 comes from 0.95 divided by 2 because it's half of the area. So taking that information, we could see that if we multiply 1.96 by the standard error, then our confidence interval will be 10.998 plus or minus and when we do the computation, it's 0.00392, 0.00392. All right. So if we expand that, we will get 10.99408, and so the mean is less than or equal to this, greater than or equal to this value, or 11.00192. All right. So that's our answer in terms of the confidence interval. This is what we've calculated for this question. So that's our answer right here. So we could write a statement that says we are 95% confident the true mean length of the paper lies between 10.99408 and 11.00192 inches. We have a 5% chance of being wrong. That means that there's a 5% chance the interval does not contain the mean. Now the question is this manufacturer producing an average length of 11 inches? We cannot say that they are not, because 11 inches is actually contained within the interval. So if you look at the interval, 11 inches is contained within that interval, and so therefore it is quite possible that the manufacturer is producing to an average of 11 inches. Okay.